I don't know if we are live. We are supposed to be live. Hello, welcome everybody. I'm sorry, I just had a problem with my laptop when it was going live. So welcome to the community open hours. Usually we start with Denis. Denis is on holidays, but I have another colleague as a guest. Brett is there. Hello, Brett.
Hello, how are you?
Good, good. Maybe you can introduce yourself quickly, and then I will have some highlights, and then it will be your demo on the topic that we have set for today.
Sure, yeah, I'm Brett Hoyer. I work with Denis on the developer relations team here at Yugabyte, primarily working on developing applications featuring emerging technologies in the database space and how they fit in the Yugabyte ecosystem. So that's sort of what we are going to be going over today, an AI multimodal application that I've developed and how to get started using LLMs with Yugabyte.
Yeah, and so if you follow the Yugabyte blog, if you look at the sample application that we do, then you probably have seen some work from Brett. If people in the chat can just say hello in the LinkedIn chat or YouTube chat, so that we are sure that we are streaming correctly. Usually it works, but always better to check. And also, if anyone has questions, the goal of the community open hours is also to answer directly questions or get feedback from users. Before we start with the demo, we have usually a few highlights. I wanted to share the next conferences where we are to advertise a bit for the conferences also. Let me share quickly my screen. I will start with one where Denis will be soon. That is Explore in Las Vegas. Let me put that a big larger in August. And he will be talking also about generative AI. That's the trendy topic now. And I will be in Postgres Ibiza end of August, beginning of September, with a more classical topic, isolation level in MVCC. So if you go to those conferences, please say hello if we are there, and I really recommend everybody to go to conferences when they can. And as another highlight, I also would like to share one blog that we have. And I'm sorry, my laptop is very slow, but I'm sharing the screen there. We have a blog on blog.yugabyte.com where we publish, I don't know, 2 articles a week, something like that. And one that is very interesting for maybe for users who are interested by how the database is built. We have a colleague who detailed the kind of tests that we are running continuously on new versions to be sure that there are no regressions before releasing a new version. And we run tests also for performance, like TPCC with 1,000 warehouse tests, sysbench, so the common benchmark that people know. So that's also something people are asking. We are a new database, we build new features, and of course it necessitates a lot of tests, like any development, but more important when it concerns data. Okay, I will check in the chat if we have some feedback. We have Pete saying hello. Hello, Pete. Pete, if you have any questions, do not hesitate now or during the demo or at the end of the demo. And for the moment, then before we have any more questions, Brett, the stage is yours. You can share your screen when you do the demo. Explain quickly what you will show us.
Sure.
And
Will
let's
do.
go.
Let me share my screen and we can get going. So I'm essentially going to walk through this application that we're viewing here. I have the database running on my machine right now in Docker, but shortly I'm going to tear down this database and actually show you all of the steps to get up and running with Yugabyte and pgvector. So we will be using Postgres. You know, Yugabyte is Postgres compatible. We'll be using Postgres as a vector store for an AI-backed application. So this is the application. It's quite simple, or the UI at least is quite simple, in that you can present the application with text or an image in order to search the database for an Indian recipe. So by using a multimodal LLM, multimodal meaning an LLM that is able to interpret both text or an image, and as this AI ecosystem is developing, there are more and more features being added. You know, you're able to speak as well, and your speech can be interpreted. As we can see here, the image description is generated by the multimodal LLM. And then this description is embedded in order to execute a similarity search against our database. So what does embedded mean? Essentially, an embedding model is able to take this chunk of text and generate a 736 dimensional array of floats that is a representation of this text. So based on the embedding model, you'll get a different number of dimensions. For instance, this application that I've developed also works with OpenAI embedding models, which have 1,536 dimensions. So, you know, whichever LLM provider you choose, you'll need to set that number of dimensions aside in your database with pgvector, and I will show you exactly how that works. But our image of butter chicken has yielded a result set that is fairly representative based on what was found by the multimodal LLM. And these are all results coming from our database. So I can show you here, this is a diagram of the architecture that I've put together just to show all of the moving pieces. This is actually, I'm reluctant to say that this is a simple application, but once you understand the various components, it really is just a fairly simple REST-based web application with a little bit of LLM magic sprinkled in. So the first step to getting an application of this nature built is offline. We have a data set of recipes that I've found, over 4,000 in fact, and I've downloaded this CSV that comes with a name for each recipe, image URL, description, and so forth. And I've created a script which generates embeddings for the description column of each of these recipes and outputs a new CSV file. So this script, I can show you here, it reads in the CSV file and it iterates over the description column of each recipe and calls a generate embedding function on that description column, then outputting a new file, output with embeddings. So it takes in this CSV file, which I just showed you in the browser, but just to show you here, all of the columns are living inside of this repository. And we can be sure to provide you with links to the sample application, and you can ask any questions that you might have in our community Slack if you should choose to run this application on your own. But this generate description embeddings file reads in this CSV and then is able to output the embeddings for us. So I can show this generate embedding function. The generate embedding function is extremely simple. It just reads in that description column, and based on whether or not you've chosen to use an OpenAI embedding model or an embedding model run using Ollama, which I will show you shortly, it's just using the CLI or the SDK rather to generate embeddings using a model which is running. So that is an offline process, and once all of these recipes and their respective description embeddings are stored in the database, we're able to send text, image, or both to an API layer. So this API layer is just a simple Python Flask API layer. And if an image is sent to this search endpoint of the API, the image is base64 encoded and then sent to a multimodal LLM to generate a description of the image. So now, actually, there are embedding models that can directly take images and text. This is fairly new. Historically, most embedding models have only been able to take text. So what we are doing in this application is we are first sending the image to a multimodal model to generate a descriptive text of the image. And then the embeddings are generated. A different model is used to generate embeddings for that description. So if you've sent a combination of text and an image, then I am concatenating those two things to generate an embedding of both of them combined. And then the API server uses those embeddings to create similarity search to query our database to provide results to the end user. So that is what you are seeing here. So why don't we dive into the code, Frank, and we can show people how this works. I guess what I'm going to do first, I'm going to be brave and I'm going to delete our underlying database. And let's go ahead and
let's start from scratch.
Let's build it from scratch. And if things break, then we have an opportunity to show people how to get them running again. I think that is always fun.
Yeah.
So when we are running our database in Docker, I guess I should mention that Yugabyte can be run in the cloud, on premise. There are numerous ways of running the database. For demo purposes, I like to run directly on my machine. So I'm going to first delete my data directory, and I'm going to remake it. And then I am going to run some commands here. Let me see. I want to get my notes so that I can create what we need for this. So I'm going to create my database again. And this is all within a network called custom network, very creative name there. And that,
yeah, of course, on Docker, you need a network because you have 3 nodes here that must communicate. So either you create the network and then you start with Docker run, or sometimes I use Docker Compose that creates a default network.
Exactly. Docker Compose makes life a bit easier if you have a more complicated deployment. We have our 3-node cluster now running in Docker. And of course, there are so many ways of doing the exact same thing. What I'm going to do right now is I'm actually going to copy some files into my Docker container so that I can run a schema file. I can copy over all of the database records to my database. So I'm going to start by, this application runs using either Postgres or Yugabyte. So I think this is the name of my first container. So I'm just going to create a directory where I'm copying these files on my first Yugabyte node here. And then I'm going to copy over the schema file. Oh, I'm copying from the wrong. And I'm going to copy over my output with embeddings CSV. So I'm not going to actually run the script to generate the embeddings, but we will show that they do in fact exist. So now that we have those files on our Docker container, we can actually execute the file on the database. So this schema file can be run, which creates the extension in this case being pgvector, which allows us to store our vector embeddings and execute similarity searches. And it creates a table for us. So let's show the schema. As I mentioned, this is a very simple application. We're just using the vector package, the extension in Postgres and Yugabyte for pgvector. And here we can see the embeddings column on our table, which has 768 dimensions. That is because the embedding model that we are using has 768 dimensions. So this embedding model running in Ollama, which is a tool that allows you to run LLMs locally on your own machine. It's just an amazing tool for doing any sort of exploratory development, or if you just don't feel like paying a monthly fee to OpenAI or Mistral or elsewhere. I would highly recommend users to check out Ollama. So I'm using this tool to run both our embedding model and our multimodal model for this application.
So I guess it's a bit slower running it on your machine than on a web service, right?
Exactly, yeah. So for instance, for Lava, which is the multimodal model, there are multiple different distributions. So if my machine were larger and had a lot more RAM or GPUs, you could run the 34 billion parameter model. I'm choosing to run the 13B model, which is slightly preferable to the 7B model. From my research, people seem to indicate that this 13 billion parameter model does yield significantly better results, which we would expect. But for demonstration purposes, the 13B one is more than adequate. Okay, so we have run.
And you mentioned that one is not paying for a service. The other reason is that maybe you have some data that you don't want to share on a public service. Probably the recipes is
Absolutely.
okay, but
Yep. Yeah. For the Indian recipes sample data set, it would be certainly fine to use OpenAI or something, but with customer data, that is definitely an evolving conversation. And it seems that people that are working in AI seem to indicate that about 50% of their customers bring up that as a major concern. So it is definitely nice to be able to run, and you can also fine tune models and run them on your machine. So that's another reason. You might not want to be using a publicly available model. You might want to be running something that you've actually worked on yourself as well. So we have the schema in our database. So now we are going to execute a command to actually copy over our CSV file with embeddings to our database. So we can see that we've copied over 4,236 records. So why don't we see if we can actually run the YSQL sh command line utility to check out our database. Let's see. So I will be running bin YSQL sh, and the host will be Yugabyte DB node 1 because we are going to be inside of that network. Okay, so I've connected to my database here, and then we can, let's see what we have in here. Okay, so we have the recipes table in there. So let's count the number of records. And we can see that we have, in fact, copied over all of these records to our database. All right. So we have our database set up, and we are able to execute similarity searches on the database. So now we are able to run our application. We can see that I've done this previously. I'm going to just stop the application to show that everything is being done live and nothing is contrived here. I have our UI running as well in development mode, which points to this backend server. So we can show that this application is running. But before actually refreshing the UI and showing a live demonstration, why don't we actually show some of the code and how this is working? So we are connecting to our database locally here. We can see the database connection details in our environment file, which is loaded by the server. And we are specifying that we want to run using the Ollama ecosystem. So that's just used in control flow throughout the application to choose between Ollama or OpenAI. As I mentioned, we can use OpenAI as both a multimodal LLM as well as an embedding model, and they are continuously putting out different embedding models. If you choose to run this application using OpenAI instead of Ollama, you will just provide an OpenAI API key. So sticking to our theme of being free and running on our machine, I'm just using Ollama here with the Nomic embed text embedding model and Lava for the multimodal LLM. So walking through the API layer, we are connecting to Postgres by default if you should choose not to provide your database details. But as I mentioned, we are working for Yugabyte DB, and I would like to run Yugabyte instead. So that is what I'm doing. And we have a simple search endpoint that the UI points to. This endpoint checks to see the multi-part form input, and it's checking to see if we've attached an image. If an image is attached, then the describe image function is called. So the describe image function, which is in a different file, LLM interface, this image first base64 encodes the image using this helper function above. And then it is sending a message to the multimodal LLM. First, a custom prompt is attached. So this prompt is something that I've created. Of course, working with LLMs, crafting a good prompt is of paramount concern. I found that even just changing very minor things in my prompt has yielded very different results. And sometimes you might want to make changes, between different models that you're using. So playing around with prompting is very important. In this case, I've wanted to prompt the LLM to act as an expert in identifying Indian cuisines, identifying the likely ingredients, and providing a description for us in 2 to 3 sentences. And this has seemed to work out pretty well for me. And after describing the image, after crafting this prompt, the prompt is passed to the LLM as well as the base64 encoded image. You can see there are slightly different method signatures between the two ecosystems, be it Ollama or OpenAI, but they're generally doing the exact same thing. So this image description is returned from the multimodal LLM, and then later on can be concatenated, and this embedding query, if we've attached supplementary text, maybe we don't trust the multimodal LLM to fully be able to pick up on the image, or maybe we have some clue of what the dish is, but we're not entirely sure. We might supply some additional text as well that we want to add to our embeddings. And this text can then be provided in addition to the generate embedding function that is the exact same function that we used in our very first offline step to generate embeddings for each of our recipes. And this is actually fairly important because you need to use the exact same embedding model on both ends. The embedding model that is used to generate embeddings for our data set to store in our database needs to correspond to the embedding model that is used by our application. So every time...
Just to understand, because the embeddings are those float numbers, and they have no signification beyond the model it belongs to, right?
Yes, exactly.
It's not that it is approximate, it's completely different. It's like taking a binary file without having the specification of the file, right?
Yep, exactly. So for instance, this is a question that comes up quite often at AI presentations. People want to know, should I have changes to my data set or come across a new embedding model? What do I do? And essentially the answer is that you need to generate a whole new batch of embeddings for your entire data set. for instance, if you were trying to compare embeddings from OpenAI's model to those of Nomic embed text running in Ollama, not only will you have a mismatch based on the model itself, but also the number of dimensions is different. We're storing 736 dimensions in our database at the moment, where OpenAI's model generates 1,536. So no similarity search can be executed. So we need to be using the exact same embedding model.
Yeah.
And
Pete is saying clear same model to have searching correct model is your secret sauce. And something coming to my mind. That means that if I store embeddings in my database and I back up my database because maybe for legal reason I may have to restore it in 5 years. That means that I should also back up the model that goes with it, probably. And I'm sharing also, we have Cheyenne asking, so from New York, Rainy, and asking for the slides and code samples. I think you have a blog post about this.
I can provide all sorts of additional resources.
I think I have it.
Yeah, share the blog post. I can also answer any questions in our community Slack that might come up. That's a great place to stay connected with us after this talk, if anything else comes up. But yeah, we will be sure to share the sample repository and blog post so you can check it out further. So yeah, that's a great point.
Shared the blog post, and I think you link to the repository on it. Yeah, perfect.
There are also certain tools. There might be more questions about, what if the data set changes? I'm presenting this as an offline process where we have a big data set, but what if a user adds a recipe, or this is an application where people are uploading things continuously? There are some tools being developed based on pgvector in the Postgres ecosystem, where you can actually create hooks into your database where as records are being written to the database, these changes are constantly being watched, and a process can be kicked off to generate embeddings and update the embeddings column thereafter. So there are some pretty cool tools in the Postgres ecosystem that are additional extensions that can be installed and used. So that might be something cool for people to look into as well. So yeah, that covers that bit there. And the embedding is generated. So after we have generated an embedding, we can actually use that embedding. So just to make sure that we're all on the same page, we've generated an embedding based on the combination of the description of the image, so the text that is returned, the 2 to 3 sentences that we have asked for in our custom prompt of the multimodal LLM, and any text that was supplied from the UI via this search query. And we have the ability to now query our database using similarity search and pgvector. So we are querying for a name, description, instructions, and an image URL from our recipes table. And we are ordering based on the embeddings using cosine similarity search, and we are returning 10 records. So what this is doing is essentially comparing the embeddings in our embeddings column to those that have been returned from the embedding model, and ordering by cosine similarity search to return the most representative results from the data set. So I hope that is all clear. I don't know if there's anything on your end, Frank, that seems like I have sort of waved my hands and not adequately explained, but I think that for the most part covers it. I would like to show the application running so we can see what is output and show as well what is happening behind the scenes. I think I have run everything. So we can see that a file is being captured and I'm logging certain things for demonstration purposes. This takes a little bit of time. The image description has been generated from the multimodal LLM, which I'm running here in Ollama. We can see that I'm running Lava 13b on my machine. This command line utility is available when you install Ollama on your machine, and we can see that I've previously listed the different models that I've installed and played around with. You can run, as an aside here, you can run the Llama 3 model and you can just ask, use it just as a question answer service as well. Like I had mentioned previously, if you don't want to pay for OpenAI, you are getting more.
So you have your ChatGPT on your laptop.
Exactly, and it runs quite quickly. I'm soon going to start looking into which models are best at generating code or helping me debug while I'm building applications. There are a lot of applications for Ollama, and they're constantly supporting additional models. You can find models through Hugging Face as well, which is a great resource for finding open source models that you can use or you can train on your own.
I have a question. I didn't look at the details on there. When you go to Hugging Face, for example, do you have a clear description that will help you to choose the right model, or finally you have to kind of test all of them on your use case? I mean,
yeah,
is the description really clear? Like, for example, where you read the description and you know that because you have Indian recipes and food images, you know exactly which one is better.
Yeah, so this ecosystem started off being quite confusing. This is my own personal opinion, where even the frameworks that are developed to help us build applications such as LangChain or Llama Index, everything is being developed so rapidly that sometimes the APIs are changing so quickly, and it's if you're looking for help on Stack Overflow or elsewhere, the code samples are outdated. Even just a few weeks after an answer is provided, because everything is being developed so quickly. But this is just rapidly improving. Things are getting better so quickly. You can see that you're able to filter by all of the different things that you might be looking for, be it here right at the very top. I haven't even looked at this previously. We're seeing multimodal models, and we can filter by visual question answering, image text to text. We can click on one of these and we can see the different versions. They provide comparisons between them by different benchmarks. And you can also fine-tune these models as well. So for instance, Facebook open sources a lot of their models that can then be fine-tuned in order to serve a particular use case. So say that a general model is able to, take an image and provide a description on it. You might only have a very specific use case. Let's see, off the top of my head, I'm thinking a live video feed from a surveillance camera wants to be able to determine if people are stealing items from a store or something. The model might be able to fine-tune, might be able to be fine-tuned to serve only that very specific use case. So that is something that is available to you by using these open source models.
Okay. We had another question
Sure.
from Cheyenne. Was about the comparison. You used cosine, and the question is there guidance on when should you use cosine versus Euclidean or other distance operations?
Yes, absolutely. So let's see. Whoops, this is a blog that I've created in the past. Here we go. So this is the pgvector extension, and the documentation here is actually quite good. You can see that this is a very active repository with some very, very prominent people in the Postgres ecosystem working on this. But they are constantly adding different operators based on your particular use case. We use cosine distance for our similarity searches, but I've actually created a full blog post for pgvector, the different indexes that are available to you, and additional indexes have been added in version 0.7 as well. But we can also provide this link for you, Yugabyte pgvector. We can provide this blog post to you as well, where I explain the different operators. I try dumbing down the explanations of, you know, what embeddings are, the different operators, when you would want to use the cosine distance or cosine similarity, the L2 distance. So this gets a little bit mathy and as in-depth as you would like, but that information is available to you as well. So we can provide you with those links, and obviously happy
the link
to answer
in
any
the
questions.
chat.
So back to our, I know we're hopping around here, but I think this is all pertinent information, trying to make sure everyone is clear on the tools that are available to them. Because, you know, I can show how I developed this application, but as I mentioned at the onset of this open hours, this application could have been developed in so many different ways. Like there's a lot of tools available to us. So I partially wanted to show how this application was developed and how you can run it on your machine, but I feel like more so I just want to show people how simple it is to get up and running using this ecosystem, and show that it's really not very difficult to get started adding a lot of this functionality to your own applications. Just to show you the logs for what actually happened, to explain the steps that we've gone over in the code. The description embedding was created for us, and then it was immediately run against the embedding model to generate this 736 dimensional array of floats, as we mentioned, for our nomic embed text model. So this chunk of text was translated into this array of floats. And then we used this array to query our database to order our results by the embeddings column using this vector. And then we are seeing that the post returned and the UI has asked for these images for the various recipes that were returned from the database. So we've provided a photo of garlic naan, and we can see the image description. I've just chosen to add this to the UI to add a little bit of additional clarification to the end user. So it was identified as golden brown flatbreads, likely naan or roti, yada yada. Very representative of what the image actually is. And we can see that butter garlic naan was the top result, in fact, from the database. And this won't always be the case. Sometimes you'll search, for full transparency, sometimes I'll search and garlic naan won't be in the result set, and there will be other breads. See here, even we're seeing mushroom paneer masala, which does not correspond to this bread. Most of the results do, in fact. But this is a perfect example of how you need to play around with these tools, checking the different models that are available to you. Maybe that 34 billion parameter model will yield significantly better results, or by creating a different custom prompt and supplying that to the multimodal LLM, you might get better results. But for the most part, this is quite effective, and I've used this not only in this little sample application, but we can think of many great use cases for this functionality in e-commerce applications where we're using a multimodal LLM either to generate descriptions of images like we're doing here, or generating shortened captions for images, allowing users to search a product catalog based on something that they have seen in the wild. Maybe you see your friend wearing a cool shirt and you would like to wear the same. There are multiple different use cases for this, and if anyone out there watching this has a use case of their own and can't quite think of how they would go about building something, please let us know. We're always interested to hear how users of Postgres or Yugabyte are interested in these technologies, so that we can continue to think about these things, build applications, write blog posts, and further along this ecosystem and help people out however we can.
And Shayon is saying, getting hungry already. And we have also a question. We have also a question from Anil. What do you think of Julia programming language? I don't know anything about it, so the question is for you, if you have an idea.
I wish I could tell you. I don't have any experience, but there we go. Maybe I need to look into that next.
Yeah,
I know Denis.
We will look at it and see what we can do with a database and Julia. Yeah.
Denis has been using Elixir a lot recently. I know that is a new language that he's been playing with, but I have not used that one yet.
And I've heard a lot of people talking about Elixir. I don't know if I'm more aware because I discussed with Denis of it, or if it's really the trend in the last weeks. But I've seen many users telling me that they are looking at Yugabyte and for Elixir applications. So
exactly, yeah. For these AI applications, it definitely seems that Python is the prevailing language used. I know, obviously, Python has been used heavily in data science for a very long time, and a lot of the tools that are leading in this community, like LangChain, which I mentioned previously, a lot of them work across language, be it Python, JavaScript, or others, but it seems that Python is used most heavily. So that's why I built this application in Python, but they're moving over to Java and elsewhere as well. So that's all I have in terms of this presentation. Obviously, happy to answer.
That's perfect. Let's see if we have questions. And that for the moment, we have pgvector in Yugabyte. For the moment, we don't have indexes on them.
Mm-hmm.
I didn't check recently. I know that we have colleagues working on that, looking at the different algorithms and which one makes sense for a distributed database, because we don't want just to implement indexes like they are in Postgres. We want to use the fact that we have a distributed database and we can distribute the search on them. I don't know if you know more about the latest state on that, but I know that there is some active work on it.
Yeah, I know that this is actively being worked on, and more so. I'm also just thinking now that if people would like to watch additional presentations on pgvector specifically and why you might want to look into using it as a primary vector store in lieu of using Pinecone or another vector-specific database, I have some really great talks that I'd be happy to share with our community. From one I can think of from Jonathan Katz, who is a maintainer of pgvector and an active contributor. And then there's another talk that I would like to share with people from Andrei Karpathy. It's just a general talk on LLMs that Denis had shared with me that I thought was really great and has, potentially millions of views on YouTube at this point. So if anyone would like those, just ping us and reach out either on LinkedIn, community Slack, wherever you can find us. And I would certainly be happy to share any additional details.
And I've seen also that we have some internal discussions that were recorded about choosing the right index, and probably at some point we will do a session on it, or maybe on the YFTT on Friday, because the research to see it has also evolved a lot. The different indexes, there are some trade-offs between the time to build the index and also maintaining it.
Exactly. It's a trade-off between how often you need to build the index and how fast you want to be able to query on the fly. So if you have a data set that's unlikely to change, you might want to choose one index over another. But it's pretty cut and dry beyond doing your own performance testing. I've laid out some of the groundwork for the IVF flat and HNSW indexes, which are the two most popular ones in pgvector before these new ones that I mentioned came forward in release 0.7.0. So you can read all about that in the blog post that Franck has shared.
Yeah, and you mentioned presentation from Jonathan Katz. Also, Neon, the DevRel team also shared a lot on around pgvector. They did PG and embedding.
Timescale and Neon both.
And timescale also, yeah.
And to answer Pete's question, SciCop, the connection is fine from Python to Yugabyte. We also have documentation for the various smart drivers that are language specific that are available from Yugabyte, which can help you with load balancing and making your driver cluster aware, which is important in a distributed database, so that you can load balance requests across the various nodes of your database. So that's something that's kind of cool that you can look into if you want to search for the smart drivers on our documentation.
Yeah, basically we fork the Postgres drivers. The Postgres driver can work directly, but they need a list of hosts to connect to, or HA proxy in front of the database. With the smart driver, we make them cluster aware, where they can discover if there are new nodes, if some nodes disappeared, and then the connection pool can connect to the right nodes. And we have also another question from Anil about Julia, or question or just feedback. Julia was aimed to replace Python for data science, but not adopted by the industry. Julia as native ML library, not like Python. Okay, where most libraries are written in other languages.
Very cool.
Yeah, it's about the languages, but also all the libraries that come with it. And
I'm sure we have people at our company who are much more equipped to answer that question. I'm more floating around between languages as an application developer, so I haven't gotten too deep in the weeds in the ML, unfortunately, but I would love to do so. So maybe you've just given me an excuse to check that out more readily.
And there is too much. We have to look to a lot of models. We have to look to a lot of languages and their libraries, and yeah, that can be a lot.
I would love to fine tune a model for an upcoming community open hours or a Friday tech talk. I think that would be a really cool thing to see what tools are available to fine tune a model, be it one like this or just, a standard LLM. I've built applications building AI agents and retrieval augmented generation applications, like every type of application I think that you can think of. For the most part, we have samples available not only on our GitHub, but you can also find them directly on our documentation. So you can see some little applications that I've developed using LangChain, Llama Index, and so forth. But of course, like I will say over and over again, just ping us if you have any questions, or if you're having trouble running something on your own machine. We're always happy to help.
Yeah, we have no more question, and it's just time. So yeah, good to mention that we are open not only on the open hours, but we have Slack, we have forum, we are on social media. So the goal, we build an open source database, and the goal is also to discuss with the community of users, not only the commercial customers, but a wider community, because more ideas come from it. And also I will mention that if you test Yugabyte for whatever, it's always good to have feedback for us as developer advocates. It's good to help people, but also to improve the documentation. Feedback also helps to improve the product. We already mentioned a few things that are in the roadmap, like indexes for pgvector, and there is a lot to do, and the more users ask for something, and the higher priority goes to it. So if we can gather feedback about the usage, it also helps to build the features faster when we see that there are people asking for that. Okay, thank you very much, Brett, and thanks everybody. Also mentioning that this is live, but also available on YouTube. And we do these open hours every 2 weeks. And usually Denis is there. I think it's the first time he's not there. He's on holidays. And we will have him in 2 weeks. Thank you. Goodbye.
Thank you. Have a good one. Bye.